Hello, you're welcome. All right, so here we're going to be looking at circle. Okay, the introduction to a circle. Now, what's a circle? A circle is actually the locus of a curve equidistant from a point. Okay, so as you can see, I've actually this is a circle. Now, every circle is has a curve. Okay, and that curve actually go around and is equidistant from a particular point, and that point is actually the center of the circle. So I have a circle here, okay, and then the center of the circle has a coordinate a comma b. So the study of circle in this tutorial, okay, I'm going to study circle based on coordinate system. Okay, so where I will actually represent the center of the circle by a point based on its coordinates. So this center of the circle is a comma b, right? And of course I also represent the circumference of the circle by the coordinate x comma y. So now you know very well that in a circle the distance from the center to the circumference is always the radius. Okay, the distance from the center to the circumference is always the radius of the circle. So now what am I going to be doing with this? Okay, now every circle there's an equation that created a circle. So what I'm going to be looking at is the equation of a circle. How do I actually form equation of a circle given the center and the circumference? Equation of a circle. All right, so before we actually derive the formula for the equation of a circle, let's still take note that a comma b is the coordinate of the center of the circle. Okay, this is the center of the circle. Then x comma y, okay, being the final point, okay, from the line that actually join the line from the center to the circumference, okay, is actually the circumference. Is the circumference, and that becomes my my two variable, which of course is s y coordinate. All right, while the r there represent the radius of the circle. So now please take note of that. So if I need to actually establish or derive the formula for the equation of the circle, I'm going to use all these parameters, and that's going to be, I'm going to establish a relationship for the radius of this circle based on Pythagoras rule. Okay, remember, if what actually forms this radius of the circle is going to be the increment in x. Okay, we've talked about that when we did coordinate geometry, increment in x, and of course the increment in y. So this is the vertical is the increment in y, and here is the increment in x. Okay, so of course from this I've ended up forming a right angle triangle in which the increment in x is the adjacent and the increment in y is the opposite. Okay, so according to Pythagoras rule, you know very well that the r square, being the hypotenuse square, is equal to the adjacent square, the increment in x square, then plus the increment in y square. Okay, so already we know how to evaluate increment. Now increment in x, of course is going to be x2 minus x1, but in this case s2 that becomes by x, okay, and s1 becomes the center, which is a. So increment in x is going to be x minus a, then all square, then plus increment in y, that is y minus b all square. Okay, so this is the standard equation of a circle. R square is equal to s minus a square, y minus b square. Okay, where a and b are the center of the circle. X, y, okay, remember the equation every equation must always have x and y variable. Okay, So while the x, y actually still remains my dependent and my independent variable. Now the question is, how can I be able to, how will I get this radius? To get the radius, okay, to get the radius, we apply Pythagoras theorem, you know very well. The radius is the length of this line, okay? So of course I've shown you how to evaluate the length of a line and when we treated coordinate geometry. So invariably now the radius will be equal to the square root of x minus a all square, then plus y minus b all square. Okay, so this is the formula for the radius. Now basically everything will actually we use this, but let's look at some example. Okay, so let's pick some question and evaluate it so that you actually understand this better. Okay, so the question goes like this. Let me clean up. Find the equation. Okay, you'll be asked to find the equation of a circle whose center with the center coordinate. Center is 2, 3. Then of course radius, and the radius is equal to 4. As simple as that. Okay, so solution. The formula for the equation of a circle, remember, is r square equal to x minus a all square, then y minus b all square. So the radius is 4, so I'm having 4 square is equal to bracket open x minus, remember is a is actually the x coordinate of the center, which is 2, so that's going to be then plus, okay, y minus b is the y coordinate of the center of the circle. This, the y coordinate is 3. Okay, all square. All right, so with what we have here, of course you know very well that 4 square is 16. Expanded this, okay, the shortcut to this expansion is as good as just going through the log cut, okay, where you have to multiply this bracket. Of course you know very well that s minus 2 square, okay, is written as s minus 2 in bracket, then multiply by x minus 2, okay, then you expand. But I'll just go by shortcuts. What's the shortcut? I'll square the very first, okay, the very first element or term here, okay. And I now use the square, the 2, multiply this and this 2 times x times minus 2, that will give me minus 4x. Then finally I now square the second element. All right, minus 2 square, that gives me plus 4. That's the shortcut. The same thing goes, square y first, y square, use 2 to multiply y and minus 3. 2 times y is 2y, 2y times minus 3, that gives me minus 6y. Then I now square minus 3. If I square minus 3, I'm gonna have 9. Okay, so here we go. We collect like terms, right? So I'll still collecting like terms. Okay, what I will do, I will rearrange this equation, right? First I'll start with s square. S square doesn't have any like term, okay? Minus 4x doesn't have any like term, okay? Of course, minus 6y doesn't have any like term, okay? So my constant value has like term, so I have plus 4 plus 9. Then I have to take the 16 to the other side of the equation, right? That's minus 16. Then everything is equal to 0. Okay, so let's do this. So this is going to be equal to s square minus 4x minus 4x minus 6y. Then 4 plus 9 gives me 13. Then 13 minus 16. What do I have? That should be minus 3. Okay, so minus 3 is equal to 0. So that is the equation of that circle. As simple as that. Okay, so now it's easy. I can actually bring another. We can look at another example. Let's look at another example in which the center, okay, is 1,2 and the radius is 2. Okay, so of course the equation, don't forget, is r square bracket open x minus a all square then plus y minus p square. So here r is 2, so I'm having 2 square x minus s coordinate of the center, which is 1 square, and plus y minus y coordinate of the center is 2, so this is going to be 2 square is 4 equal to x square 2 times x times minus 1, that's going to give me minus 2x minus 1 square is plus 1. The same with this y square 2 times y times minus 2, that's going to be minus 4y then plus 4. Collecting like terms, okay, so I'll have x square minus 2x, okay, minus 4y then of course I'll start adding the constant, plus 1 plus 1 plus 4, then this goes over minus 4, all is equal to 0. So if we have this now, my answer now is going to be equal to x squared minus 2x minus 4y. Okay, 4 minus 4 is 0, so I'm left with plus 1. All is equal to 0. Okay, so I hope that is well understood. Now, this is how to actually evaluate the equation. But let's look at a situation where you are being given an equation and you are being asked to find the center, okay? So we're going to evaluating the center, and the radius, the center coordinate and of course the radius from equation. So how do we do that? So let me see, if you are being given an equation and you are asked to evaluate to get the center coordinate and the radius of that particular circle, how can you do that? Okay, for example, let's say you are being given x squared minus 2x plus 4y then minus 1 equal to 0, and they are being asked to find the center coordinate, center a comma b, okay, and of course the radius. How will you do that? Okay, so now there are two ways to do that, okay? Either by formula or you go by completing the square. I think I should actually go by formula, okay? How do we actually go by formula? Now um, let's get uh, go to our normal equation of a circle, all right? We'll have r squared equal to x minus a all square. Then of course y minus b all square. So now look at what I'm going to do. Of course, I will have to expand this. Expanding this, okay, here I have r square. Okay, so now you discover that first step, note that the a and my b is my center coordinate, okay? A is my s coordinate of the center, yb is my y coordinate of the center. So I'm going to simplify this equation. Then of course we generate formula that will help us to find my a, my b, and my radius r. Okay, so let me expand this. Of course, you know how we do that. That's going to be s squared 2 times x times minus 2. That's going to be minus 2x. Then of course plus a squared. The same thing happens here. Here I have y squared 2 times y minus b. I have minus 2by. Okay, then plus b squared. So you know what we do? We rearrange the equation. Okay, so the general equation. So for me to be able to solve this particular this problem, okay, I have to create a standard equation out of the equation of a circle. So now this is one way of actually expressing the equation of a circle, but the one I'm actually going to give you now is the standard way, standard form of equation of a circle. So now let's go there. So I'm going to have s squared, all right, and of course minus 2ax. Okay, then minus 2by. Okay, then of course I collect the constants together. The constant I have is a squared, then of course plus b squared. Then of course r squared comes over, becomes minus r squared. All is equal to 0. So now I'm going to separate this into this. Now I have minus 2a, which of course is the coefficient of s. If you compare it, the coefficient of s is minus 2. I have minus 2b, which is the coefficient of y, that is 4. Okay, so let me use g and f to represent those coefficients. Okay, so let's g represent the coefficient, and of course with the minus sign. Okay, so let g be equal to 2a, then let f okay, let me I'm using, please rather I'm using f, okay, of course in alphabetical order, to represent the coefficient of the x, which of course is minus 2a, and I'm going to use g now this time around to represent the coefficient of the y, which is minus 2b. Okay, so in this case now and of course all this constant term, which of course is a square, all those are constant term. Okay, they don't have any variable attached to them, plus b square minus r square. So let me use c to represent those constant terms. Okay, so I can now write my equation now of a circle in a standard form. So it goes this way: s square, then minus 2a is already being represented by g, so that's going to be plus gx. Okay, then of course minus 2b is being represented by please pardon me, minus 2a is being represented by f. Okay, so that's going to be plus fx. Then of course minus 2b is represented by g, so I'm going to have gx. Okay, then of course all the constant term s square plus b square minus r square is being represented by c, then plus c, okay, equal to 0. So once you see this, okay, this is what the standard form. standard form of equation of a circle. The standard form of the equation of a circle. So from this standard form now, you know very well, you can always evaluate my center. Okay, from the standard form now, all I just need to do is for me to get my A. Of course, A is going to be equal to F divided by minus 2. Simple. If I want to evaluate my B, Y coordinate of the center, okay, my B is going to be equal to G divided by minus 2. Okay, comma. So if I want to evaluate my radius, all I just need to do this is C, right? I have to make the radius the subject, right? So that means my radius now is going to be equal to, of course, the square root of C. If I take A squared to the other side, it becomes minus A squared. Okay. B squared to the other side, it becomes minus B squared. Of course, I have to find the square root of all of them. Why? Because array was squared. So for me to be able to get R, okay, to eliminate this square, I have to find the square root of the other side of the equation. Okay, so now that is how it is. So all I just need to do is to compare the equation that was given with this standard equation, and I'll be able to get what I'm looking for. Now, for me to illustrate that, I'm just going to use this equation I've already given you. Okay, so let's say you are being asked to find the center, okay, and of course the radius of this equation. Simple. A, which of course S coordinate of the center is F, okay, all over minus 2. And the question, what's my F in this equation? My F is simply the coefficient of X, okay, the coefficient of X. And what's the coefficient of X? That's minus 2. So that means my A is going to be equal to minus 2 divided by minus 2. S equal to 1. As simple as that. Comma B is the coefficient of y there is 4. The coefficient of y is 4, and of course G is my coefficient of y, right? That's going to be 4 divided by minus 2, which of course is going to be equal to minus 2. Okay, then the last but not the least, the square root of the constant value in this is 1. Okay, the constant value is minus 1. Please pardon me. Yes. This is because C, the constant value in this particular expression is minus 1. So that's going to be minus 1. Okay, then of course minus A squared. So what's my minus A squared? So I'm having what's my A? My A is actually 1. Okay, so here we go. So that's going to be equal to, don't forget, is minus A squared, right? So that's going to be minus into A, which of course is what I got is 1 square, then plus B square, okay, minus B square. That's going to be minus, okay, please pardon me, let me, R is going to be equal to, C is from what I have is minus 1, okay, then plus minus A square. That's minus, what's my A? My A is 1. Okay, please pardon my previous mistake. Alright, then of course plus minus now, minus B square. What is my B? My B is minus 2. okay, r square. All right, so how do we evaluate this? So invariably now I'm going to have, okay, I'm going to have, I've seen a mistake in my formula. I see a mistake in my formula. From my formula, there is a mistake. Let me correct the constant time, please. This is a square plus b square minus r square equal to c. Okay, so the mistake I made was I was supposed to take r square to the other side, then c goes to the other side. So that simply means that r square now was supposed to be a square, okay, plus b square minus c. Okay, because I discovered that what I was evaluating was giving me a complex value. Okay, so this is the right way of this is the right equation. So now that simply means now that my r now is gonna be the square root of this. Okay, so please correct that. A square plus b square then minus c. So r now is gonna be equal to the square root of the a square now, which of course from what I have here is 1 square. Alright, then plus b square. B square is what I have for my b is minus 2. That's gonna be minus 2 square. Alright, then minus c, which of course is, what's my c? My c is the constant value, remember, minus 1. Okay, minus 1. So let's evaluate this. 1 square is 1 minus 4 square. Okay, minus 2 square, please pardon me, is 4. Then of course minus 1. So you now have 1 minus 1 is 0. Okay, I have the square root of 4. So this square root of 4. So if I do the square root of 4, I have 2. So that simply means that my radius, the radius of that particular circle whose equation is given okay, as s squared minus 2s plus 4y minus 1 is equal to 0 is 2. And the center coordinates, okay, my center coordinates now, the center of that circle, I've already evaluated that. Okay, so the center coordinate is equal to, remember it's a comma b, my a was 1, then comma b, which is minus 2. So it's as simple as that. So that simply means that anytime you are being asked to evaluate center and radius from equation of a circle, just transform that equation, okay, uh, or compare that equation with the standard form of equation of a circle. That will be able to find the center and of course the radius. Okay, so we are going to look at more questions in the next video. All right, see you in the next video. Thank you very much.